Prasunjana from the Aerospace Engineering Department. On behalf of the organizing committee, it is my great pleasure to welcome you today in the first international conference on recent advances in computational and experimental mechanics 2020, which is being held at IIT Kharagpur. Today, we are honored that around 300 delegates have assembled here virtually from across the world for sharing their research. A warm welcome to all of you. Due to the ongoing pandemic, there has been a paradigmatic shift in the education sector, and teaching and conducting research online is the new normal. It was something that was previously unthinkable. The first ICRACEM conference embraces this new concept of work from home through digital platforms and tries to promote a healthy exchange of ideas solely through online means. Today's proceedings will begin with formal welcoming of our guests. We first welcome our chief guest, Professor D.V. Griffiths from Colorado School of Mines, USA. Professor Griffiths is a distinguished member and former director of ASCE and the editor of Computers and Geotechnics. Thank you, Professor Griffiths, for joining us, and a warm welcome to you. We now welcome Professor V.K. Tewari, Director, IIT Kharagpur. I request Professor Damodar Maiti to do the honor, please. Okay. Now I would like to welcome Professor S.K. Bhattacharyya, Deputy Director, IIT Kharagpur. Now I will welcome Professor B.N. Singh, Registrar, IIT Kharagpur. Now I would like to welcome Professor Swagata Dasgupta, Dean Continuing Education Program. Now I would like to welcome Professor Nirjhar Dhang, Head, Department of Civil Engineering. I would now welcome Professor H.V. Warrior, Head, Department of Ocean Engineering and Naval Architecture. To start the proceedings formally with an auspicious note, we will now have the lamp lighting ceremony. I would like to invite our respected dignitaries to do the honor, please.
नए कदम बढ़ाए हैं, साथ ही चलेंगे हम। नए कदम बढ़ाए हैं, साथ ही चलेंगे हम, साथ ही चलेंगे हम। योग कर्मसु कौशलम, योग कर्मसु कौशलम, योग कर्मसु कौशलम।
Now, I would like to invite Professor Damodar Maiti, Chair, ICRACEM 2020, to deliver the welcome address. Sir, please.
A very good morning to all of you. Honorable Director of our institute, respected Professor V.K. Tewari, Honorable Deputy Director of our institute, respected Professor Sriman Kumar Bhattacharyya, Honorable Registrar, Professor B.N. Singh, Honorable Dean Continuing Education, Professor Dasgupta, Honorable Head of the Department, Civil Engineering, Professor Dhang, Honorable Head of the Department, Ocean and Naval Architecture, Professor H.B. Warrior, and our Honorable Chief Guest, Professor H.B. Griffiths, distinguished member of former Director, ASCE, Professor of Colorado School of Mines, and Editor of Journal of Computers and Geomechanics. My dear participants, colleagues and friends, I, on behalf of first international conference on recent advances on computational and experimental mechanics, ICRACEM 2020, and on my own behalf, I heartily welcome you all in this auspicious program. Friends, we are all going through a difficult time due to the sudden outbreak of coronavirus. This pandemic has affected to almost every profession across the globe. The whole world is struggling to fight against an invisible deadly enemy, trying to understand how to live with the threat posed by a microorganism. Entire economy is under threat. We are forced to restrict our physical movement and thus unable to perform our duties in a normal manner. Students are somehow managing their study through online mode. However, researchers are unable to perform their experimental works. Under this prevailing situation, we few colleagues from 3 departments have decided to hold a conference so that researchers are being engaged to consolidate their already done work during this pandemic. Now, we thought if we can organize a conference, the like-minded researchers can interact each other and exchange their ideas, improve their research skill. The online mode is the only way under this prevailing situation, and the current technology has made us possible. Friends, for a country to become an economic leader and to remain so, research in science and technology must be at forefront of this agenda. India, being a developing country, needs to make concerted efforts towards the goal of transforming itself into a developed nation. Conference, symposia, workshop, where specialized minds exchange ideas and arrive at a significant conclusions which set the future directions of research, contribute immensely towards the realizing this goal. Friends, we from 3 different departments planned this conference in June 2020 in view of the recent pandemic, considering that research should go and get a platform to exchange their innovative ideas among the peers at the moment. And this is being organized within a very short period of 3 months. This conference has been designed under the new concept, work from home through digital platform. The entire experience, including discussions on the recent developments in mechanics, will occur online, and probably this is the first online conference in the globe which will be conducted entirely on online mode and in the view of this pandemic. ICRACEM 2020 has focused on the theoretical, computational and experimental aspects of mechanics in order to foster creativity ICRACEM 2020 will encourage promising young researchers by publishing their notable works through an internationally recognized publisher, that is Springer and Nature, in 2 different book volumes after peer review. We are very much privileged to have a galaxy of internationally reputed researchers who have kindly agreed to deliver their research outcomes. Apart from India, researchers are from all around the world. Renowned universities like Harvard University, Colorado School of Mines, Cambridge University, Virginia Tech, Technical University of Denmark, Chosun University, and many more. There has been an overwhelming response for this Congress. Let this forum staged by IIT Kharagpur be a platform for achieving the concept, simplifying the complexity. I am sure with the active participation of all researchers, academicians, and practicing engineers, this international conference will be a fruitful one. Finally, let me convey my sincere thanks and gratitude to our administration, especially Deputy Director and Director, for entrusting us to hold this conference within such a short period in this pandemic situation. On behalf of the organizing committee, I once again welcome you all and thank you very much.
Thank you, Professor Maiti, for the welcome address. Now, I invite Professor Deepak Kumar Maiti, Technical Chair, ICRACEM 2020, to give an overview of the conference. Please.
Thank you, Professor Jana. Our Honorable Director, Professor V.K. Tewari, he has kindly agreed to spare his time to inaugurate this session. Our Deputy Director, Professor Sriman Bhattacharyya, then our Registrar, all they are very busy during this pandemic situation, but still they have agreed to spare some time in this inaugural session. Our HOD, Civil Engineering Department, HOD, Naval Architecture and Ocean Engineering, Dean, Continuing Education, and other dignitaries, and my dear participants and delegates. I welcome you all in this conference. Just to give a overview of this conference, I'll say that this we didn't have the plan a priori to hold this type of conference, but in the month of after pandemic and lockdown in the month of April, suddenly one day Professor Damodar Maiti called me whether we can hold a conference, because we don't know when we will be again engaged with active research and education. So to spare our time or spend our time effectively, whether we can organize a conference. Then I told okay, fine, but he was insisting to organize in a very short period. I was telling minimum 6 months is required to organize this type of conference, but somehow we agreed. And then initially we thought in the month of August, but finally it is not materialized. But in the month of September we are able to organize. I am really grateful to all the contributory authors. Within a very short period of time, they came forward and contributed their research in this forum. Just to mention here that we have received around 320 contributory papers. Out of that, after peer review, we have selected something around 272 papers. And then we have 20 keynote speakers and invited speakers and plenary speakers. With this, we have initially also I was not so confident that we will get so many papers. I am really grateful to all speakers who has agreed for plenary, then this popular lecture, keynote lecture, invited lecture, and then our contributory authors. With their help, actually we could finally make it a success. And another thing I just to mention here, that most of the papers we have received either from IITs or NITs. We have received from some state colleges, but majority are from IIT NITs. That is a means most of the papers are in good quality. That we felt that we'll be able to publish all the papers in through this publisher Springer, who has agreed to publish our paper. With this within a very short period, we tried our best to change our reviewer to complete the review, and somehow we could manage at the last moment, and we could bring the proceeding. We'll be releasing the proceeding in this inaugural session. With this, thank you once again for participating in this inaugural session of ICRACEM 2020. I hope we'll be able to justify all the authors and their aspiration. Thank you once again.
Thank you, Professor Maiti, for the conference overview. I now request Professor Warrior, Head Ocean Engineering and Naval Architecture, to say a few words. Sir, please.
Good morning, everybody. First of all, let me welcome you all to this wonderful campus of IIT Kharagpur. Unfortunately, you cannot see the campus right now, but maybe this is the new norm, and still I am sure we will have a fruitful discussion throughout the 2 days on the different aspects of applied and computational mechanics. And with that, I welcome you again, and hope you have a nice session here. Thank you.
Thank you, Professor Warrior, for your kind words. Now I request Professor Dhang, Head Civil Engineering, to say a few words.
Good morning. Professor D.B. Griffiths, Chief Guest of the inaugural program of the conference. Professor V.K. Tewari, Director of the Institute. Professor S.K. Bhattacharyya, Deputy Director and Professor in Civil Engineering. Professor B.N. Singh, Registrar, Dean HR and Professor in Aerospace Engineering. Professor S. Dasgupta, Dean CE and Professor Chemistry. Professor H.B. Warrior, Head Ocean Engineering and Architecture. Professor Damodar Maiti, Professor Civil Engineering. Professor D.K. Maiti, Professor Aerospace Engineering. Young faculty members, those who are actively organizing this conference of Civil, Aerospace, Process Engineering and Naval Architecture departments. Invited speakers in different sessions, paper contributors and presenters, session chairpersons, scholars, students, ladies and gentlemen, welcome to this conference. I am really happy to be part of this mega show. We are going through an unprecedented situation with a fast-changing ecosystem in all spheres of our life, particularly in the education system. We are living a restricted life. The conventional education system is now facing a big challenge. We have to follow a meandering path like rivers are forced to change its course during heavy downpour, causing devastating flood, but it survives. The beauty of our education system is that we are doing our work with the aid of technology. The first international conference on recent advances in computational and Experimental Mechanics organized by Department of Civil Engineering, Aerospace Engineering and Naval Architecture and Ocean Engineering shows the trend of the present day. The technology-aided teaching, popularly known as online teaching, is being used now. As the old proverb says, the show must go on. And the good news is that the semester has started and we are taking online classes. There is supposed to be a paradigm shift in teaching. We should not take the class the way we used to take classes in a physical classroom where students are physically present. We should try to simulate the feelings in an online class. We should not start the class immediately. At least a 5 minutes assembly time should be given. Students will join in the class. Let them put their video on, microphone unmuted, and say hello to them. For a big class it is difficult, no doubt, but try to divide students in groups in different ways. We select a group and talk to them, and we can do many more things in online teaching, and it's really a big challenge and we are really doing it. Then the thing is that here in the research area, there is a high chance to change the avenue to research. The experimental laboratory works are stalled for the time being. There is a chance to change the problem from completing the work in time, and it has a long-term effect in future, because when the experiments are stalled for the time being, then obviously a particular time, that one will have a long-term effect in future. And so that is the one we should also consider. The thing is that we are digitally connected and we should be attached also. The present situation may compel us to move towards self-centeredness, or more clearly say selfishness. We should avoid, we should meet online as much as possible. And we meet in different events related to PhD program. We should not just simply go and just attend that particular lecture. We should spend some time discussing something or when the event is over. I find this particular conference starts at 8 a.m. and it continues even after the sunset, obviously as per the Indian standard time, of course. I think this conference, instead of 3 days program, it should be 72 hours continuous program when we are doing online. We could have a lecture by invited speakers across the globe at 10 a.m. say, as per their time. It may be a big challenge, one thing that participants, because there are so many participants, they are giving their lecture or their presentation, we should attend as much as possible. I request all participants to participate in all the sessions as much as possible. One thing, obviously, I am missing the lobby in the conference when we are having the physical conference happens. We used to meet that different invited speakers to discuss. I think that maybe in future it would be a good idea to have a lobby session, that where we shall meet and we shall discuss, we shall exchange our views. Once again, I welcome you all and wish this conference a grand success.
Thank you, Professor Dhang, for your inspirational remarks. Now I request Professor Swagata Dasgupta, Dean, Continuing Education Program, to share her thoughts. I think there is some connectivity issue. No. Yeah, I think there is some technical. Yeah, now she is joining, I think. Yeah, can you? Yeah, Professor Dasgupta, can you hear us? Professor Swagata Dasgupta, can you hear us?
Can you hear me?
Yeah, we can hear you.
Good morning.
Actually, I was just inviting you for your.
Okay, I lost the connection for a while.
Can you make your camera on? Can you make your camera on?
My camera is on. I guess I'm having a problem, but I can speak anyway. I don't know.
Okay.
It shows
Please
that
go
my
ahead.
camera
Please go ahead.
is on here. I'm sorry you can't see me because of some glitch in my computer, but a very warm welcome to you all at the first International Conference on Recent Advances in Computational and Experimental Mechanics. I extend a warm welcome to all the dignitaries present, our Director, Professor V.K. Tewari, Deputy Director, Professor S.K. Bhattacharyya, Registrar, Professor B.N. Singh, the conveners and heads of the organizing departments, my faculty colleagues, other delegates and participants from all over the world. A positive outcome of having an online conference such as this has been the availability of many more internationally renowned researchers and participants who would have probably been unable to join without the travel involved. And the good thing is that we can have this in all types of weather. It is extremely hot here in India now, so it's a kind of an all-weather conference. I'll just tell you a bit of what the Office of the Continuing Education in IIT Kharagpur is involved in. We have programs that are offered to working professionals from industry and research and development, faculty members from academia, students, including UG and PG students, as well as research scholars, and also self-employed professionals. We have courses that vary from 1 to 2 days over 2 to 3 weeks duration. And the concept of having a continuing education credit has been introduced, where courses enable industry participants to earn credits, and students can earn a micro-specialization in a wide variety of subjects that may be of interest, but not exactly in the curricula that they are following. We have been involved in many flagship programs in our institute, and these have involved, apart from international national conferences, workshops, seminars, symposia, we have short-term courses as well as knowledge dissemination through video conferencing. The flagship programs of the country that have been initiated from IIT Kharagpur include SPARK and LEAP. This is the first international online conference under the aegis of the CE office. And whilst this is the mode we have to compulsorily follow under the conditions, having a face-to-face interaction and networking is something that we all hope will not elude us for much longer. I wish the conference all success in the build-up for greater networking and collaborations in the years ahead. Thank you.
Professor Dasgupta, for your kind words. Now I request Professor B.N. Singh, Registrar IIT Kharagpur, to share your thoughts.
So very good morning to all of you. Professor Griffiths, Chief Guest of the today function. Professor Tewari, our Director of this institute. Professor Singh Kumar Bhattacharyya, Deputy Director of the institute. Professor Dasgupta, my colleague. Professor Dhang, Professor Barrier, Professor Maithi, all the keynote, the popular and the plenary speakers, respected Professor Tarun Khan, Professor Khan is here, all other speakers are also joining. My dear participants, members of the organizing committees, ladies and gentlemen. On my own behalf and the behalf of Indian Institute of Technology, Kharagpur, India, I welcome you all to the first online international conference on recent advances in computational and experimental mechanics. I was personally involved during the discussion and interaction for organizing such type of conference. And at that time, we are a little bit hesitant that whether a such big conference can be organized effectively in the online mode. But now, today I am very happy and glad to see that the dream has become successful. The Department of Aerospace at IIT Kharagpur with Department of Civil Engineering, Ocean Engineering and other departments, we are organizing ICRACEM conference since a long time at the interval of 3 years. And theoretical, applied, computational and experimental mechanics, there are 4 major areas of that conference. I am happy to see that this conference is a focus mainly on the 2 areas, the computational and experimental mechanics. So I can say that this conference is a more focused conference toward the mechanics. Computational sciences, now earlier known as scientific computing, and that was a need of our at that time when we started, that is looking for a complex system for solving that, and then the analytical solution, we are not in position to give the answer of that. And then with development of this, the computational science, computational mechanics has taken over all kind of, that is the analytical solution, and any kind of problems that we can able to solve it. Basically, it's a applied mechanics, is a sub-discipline of applied mechanics where we are using computational methods for solving a complex problems. And there are a lot of advances, recent advances have taken place in the computational science. And as Professor Maitri mentioned that now the quality of the paper in this conference, that is the comparatively very good and excellent quality. So I can only say that will be now the computational science is such a important and a advanced topics, and if we, our country and abroad, if lot of people are working in this area, and this is a very good indication that now so much researchers are coming forward to solving the phenomena of the principle of the mechanics. I will not take the much time. I once again welcome you all, and at IIT Kharagpur through the digital platform, we have a very beautiful campus. We are the top rated institution of the not only the India and abroad. Our alumni as a brand IITs as established all over the world, and institute has achieved a lot in the area of academic and research. And if you have all delegates and participants visited IIT Kharagpur, and it would have been better, I think, to explain all these things, how IIT Kharagpur is doing across the country, across the world. But all the speakers, plenary speakers, keynote speakers, they are all respected researchers, not only in the country and across the world, and I am sure that will be, with the deliberations and discussion focused to the computational science and experimental mechanics, will definitely going to help the new researchers and new students, those who are working in these areas. And I wish a grand success of this conference. I once again I welcome you all, and thank you to the organizing committee for inviting me and sharing my thought. Thank you very much.
Thank you, Professor V.N. Singh, for your encouraging remarks. Now, I would like to request Professor S.K. Bhattacharyya, Deputy Director, IIT Kharagpur, to share his views.
Professor D.V. Griffiths, Chief Guest of today's program, and I am sure it's good morning for you as well. It's very early morning, I guess.
Night.
No, it's at 12 midnight, past midnight. Yeah, and good morning to you all. Professor V.K. Tewari, our Director, our Dean Continuing Education, Professor Dasgupta, Professor V.N. Singh, our Dean HR and Registrar of the Institute, heads of the departments of two departments, Department of Civil Engineering, Professor Dhang, Professor Warrior from Department of Ocean Engineering and Naval Architecture, the program coordinators, my colleagues, Professor Damodar Maiti, Professor Deepak Maiti, and other colleagues from other departments or associated departments, Department of Civil Engineering, Aerospace Engineering and Naval Architecture. Distinguished speakers, I could see Professor Kong, Professor Tarun Kant and others in the participating list, and the researchers who are participating in this particular conference. Ladies and gentlemen, very good morning and a warm welcome to the first online international conference on recent advances in computational and experimental mechanics, which has been acronymed as ICRACEM. On behalf of IIT Kharagpur, I extend a very hearty welcome to you all to this conference, which has been organized by our colleagues from three departments together. Well, as it is being said that the topic is recent advances in computational and experimental mechanics. Distinctly, it tries to cover two aspects, both on computational and experimental sides. And as researchers, we always appreciate that yes, if we can simulate the physical behavior through experiments, it certainly gives us insights. We can view things how they are performing in the laboratory level and then try to understand the physical behavior. But the problem that arises with experiments is its questions on precision level, questions on the time, questions on accuracy and several other things. And also at times the experimental aspects become expensive and we cannot repeat many physical systems through experiments the number of times. And possibly in that aspect, the computational mechanics helps us in resolving that problem to a large extent. If we can simulate the physical system through a particular model, and then we can generate some computational techniques to adopt to understand the physical behavior, then at least we can study the system very precisely. And maybe through computational mechanics, computational systems, using computational tools, we can understand the behavior of the system, and possibly, if possible, we can get into the experiments to understand the behavior. So the combination of the computation and the experiment helps us to a large extent to understand the physical behavior and come up with the solution for the practical problems. In fact, thanks to the development in the computing speed, thanks to the development of different computational tools that have evolved possibly over the last 3 decades of extensive research and activities in this particular area, which have helped us to understand several complex physical systems in a very lucid manner, and thereby people can start looking into the problems which were unsolved for a long period of time. So I think the computational mechanics, experimental mechanics have a huge role to solve several problems of several disciplines. In fact, I am very happy to say that at IIT Kharagpur, we have now set up a 1.3 petaflop supercomputing facilities, which will certainly help the computational group in the campus to work more effectively, more precisely, and more complex problems with such supercomputing facilities. Let me take this opportunity to say a few words about the institute, since a large number of people who are participating in this conference possibly have not visited this campus as yet, and all I can say is that in the next opportunity you should visit this campus to see the facilities that we have. We in the IIT system, is the first IIT to set up, and in fact this year we have celebrated our 70th foundation day just few days back, and we are marching towards the platinum jubilee celebration. This is the largest campus both in physical configuration as well as in terms of the academic programs. We have about 2,100 acre campus covering a large number of departments, centers, schools, units, academy, and several such units where we are dedicatedly working in the area of academics and research. This campus, in fact, is not only, though we call ourselves as Indian Institute of Technology, not only we are focusing ourselves on the aspects of the technology, but we have dedicated ourselves to the studies of management, law, and also we have a unique school called School of Medical Science and Technology, in fact, where the aspects of the medicines are being studied with the focus on technology. And also we are setting up a hospital and eventually a medical college, which we are going to start its activities very soon. In fact, at IIT we are dedicating ourselves to active research in several areas. Some of the areas that include are in the advanced transportation systems, advanced manufacturing systems, advanced infrastructural systems, healthcare systems, geophysical systems, and so on. In fact, precision agriculture, cyber physical systems, and several other aspects on which we are venturing into. And when I really look into, I being from the area of computational mechanics as well, we really need computational aspects in each of these areas to understand the complex phenomena. Hence, this is an area which certainly needs nurturing, which certainly needs attention and discussions amongst the peers in this particular area. I am extremely happy that my colleagues from these three departments, they have come forward to have this conference in place, to have exchanges of research activities by different researchers who are working in this area. And I think such meets are absolutely essential to bring the researchers together to exchange their views so that we can solve the national problems rather than solving small individual problems. I think in that perspective, this conference certainly is going to help this community to a large extent. As it is being said by my colleagues, both Professor Damodar Maiti and Professor Deepak Maiti, that this conference has been conceived within a very short period of time. In fact, when they started the planning for it, they also discussed with us, and I being in the area, well, they said that you need to mentor it. Time to time we could discuss with them, and I could see that within a short period of time about 300 research papers have come forward. Researchers have come forward to submit their research findings, and that's absolutely encouraging. And I'm sure that the young researchers who will be listening to the experienced stalwarts in this field, and also will be exchanging their research activities, we'll get an idea that what are the areas in which we need to focus on, which are the areas in which you can continue your activities, and in time to come we can progress in that particular direction. So I extend a very warm welcome to all the participating researchers. My thanks to the eminent speakers, the stalwarts in the field, who readily have agreed to come forward, spend their nights with us to exchange their ideas, their views, and I'm really thankful to you all. Once again, I extend a very hearty welcome to you all to this first online international conference, ICRACEM 2020. Thank you very much.
Thank you, Professor Bhattacharyya, for your nice words. Now, I would like to request Professor V.K. Tewari, Honorable Director of IIT Kharagpur, to give his speech.
Good morning to all of you. On behalf of this institute, along with my faculty colleagues, my Deputy Director, Professor Bhattacharyya, my Registrar, Professor B.N. Singh, my heads of the departments, my Dean, Professor Swagata Dasgupta, and all the faculty colleagues who have tried their level best to create this particular international conference. In fact, I see that there are 3 departments who are involved in organizing this particular international conference. The Department of Civil Engineering, to which our Deputy Director belongs, and in fact he is mentoring also this particular conference, international conference. We see Aerospace Engineering, Ocean Engineering and Naval Architecture. It's really very good and a welcome sign that even during this pandemic situation where whole things are topsy-turvy and people are disturbed, but then our faculty colleagues, I congratulate them, and I wish that this conference goes very well, because they have taken a lot of pains in the last 3 months to organize. And I also hear that they have got about 323 papers for reading during the 3 days of September 4, 5 and 6. In fact, this conference of the talks of the recent advances in computational experimental mechanics. This mechanics is a subject which is so passionate to me. In fact, this particular subject, when I was in the first year, we were talked about a particular course which was known as Basic Engineering, BEC. We used to call BEC, Basic Engineering course, and one of our teachers used to talk about this. Now, the another things that I can say that the course which was taught by our teacher, one Professor Roy was there from Civil Engineering Department. I can tell you that the passion with which he used to teach, and the mechanism and the methods by which he used to explain every aspects of what a couple is and what is a force and all the moments, how to find out the loads on the beams and things like that. Later on, we came across when Professor Mandakini Ghate Majumdar, she was one of the best professors of Civil Engineering Department, and she taught us solid mechanics, in fact applied mechanics and several aspects of the mechanics aspect. Let me tell you that this particular aspect of mechanics is not only a subject of civil engineering. In fact, it is a way of life as such, because you see, right from agriculture engineering, mining engineering, see in agriculture we talk of soil mechanics. There we also talk of the nanoparticles, the nanofertilizers. Then we go to mining engineering, they talk of the various models, they talk of the various metals which they get from there and how to analyze the metals and what is the strength of those materials. And definitely you have to look for the mechanics of that. You go to naval architecture, definitely they are talking of the vessels. What happens to the corrosion for those vessels when they are in water for a long duration of time. Now we are also thinking of single particle mechanical engines. Now these are in fact these are the engines which are required, and if these engines are very smaller engines and lighter engines where materials are used. When you talk of mechanical engineering, now we have this mechanics in various names that we say, as my friends have said, computational mechanics, we know solid mechanics, we know that quantum mechanics, we know that it's also talked of the various ways of say fluidics, I think say that microfluidics and things like that, which have been employed in each and every aspects of design. Well, when we are talking of this design, we have to think of, I remember what our Madam Mandakini Ghate Majumdar used to tell us whenever she used to talk about this truss design. She used to tell us about the design of the Howrah Bridge, and she used to say that even you should think about how particular columns are there. She used to give us examples of the ancient structures which are there, say Qutub Minar, then Red Fort, and then things like various other things which are there. People used to think as to what was the mechanics at that time. I don't know what sort of mechanics they used to use, those ancient people, whom in fact if you see today, there is hardly any crack they were there. Maybe that because of the time and elapsed over a period of time, some defacing has taken place somewhere or the other, but the whole thing has been totally different. Today we are talking of certain things which are at a very high level. I remember in my department in 1989, when I got the first fluid, I mean the my FEM or finite element analysis software of Mason, I think MSc Nestor. Maybe that was the software at that time is a very high software. And in fact today I hear my friend who was talking to me that they are talking of smooth particle hydrodynamics. I think the techniques have changed over a period of time, because people are using, you say, these are being used in various fields. For example, as I can see that this is being used in mechanical engineering, the fluid dynamics, and then people are using in solid dynamics. People are using in knowing the status of what is the vibration levels. You can see that how we can sustain our buildings, sustain our bridges. We have seen the bridges in Calcutta very recently, certain bridges broken, even in Delhi. Now we see that there are certain lacuna which is there, and we need to use the mechanics. I am sure that computational mechanics, which is a recent phenomena, is definitely going to help us to analyze these, because even a small crack which happens in the bridge, we have to understand why it has happened and what may be the reasons, what is the material which has been taken. We know that because of the when we vibrations, see, vibration is one important thing which also comes into that, and there we know that the resonance takes place and some of the bridges have collapsed because of the resonance. Now these things we need to look into and to see, even the because of the various pandemics, this is pandemic, but before that we had the calamity of rain and various buildings being broken and things because of our Amphan and several calamities which have taken place. I think there is a need to look into, and these tools, the important tools which are being used, will go a long way in understanding what is this nanoparticles, and we are talking of the nanomaterials, and we are talking of advanced materials, computational, as various such subjects. At IIT Kharagpur, as my Deputy Director, Professor Bhattacharyya has said, that IIT Kharagpur we are doing several other things. For example, we have from the Ministry of Heavy Industries, we have created a facility wherein the very high-ended the manufacturing facilities could be used, and those facilities are worth maybe in the next 5 to 6 months of time. We are going to start these facilities, which will help even our MSMEs, and they can take our help, and from there also we can learn. In fact, the other day when we were there in the same facility, we have seen that one of the equipment which was very heavy and very highly high-end equipment has got damaged to some extent through a certain process. But I should say that we need to understand also the safety of these materials and the safety of these boxes. I understand that had the factor of safety would have been taken at that time while packing, maybe on the packing itself there should have been said that this is a material which needs to have a crane of so much loading capacity, while in loading and uploading there should have been some sort of a demarcation or some sort of write-up given on that itself, which might have helped. Now what I get out of that, I see that the damage which has taken place, maybe our faculty colleagues who are better off in understanding what is the mechanics of that, they should see as to how that particular membrane or that particular cover, how it has been damaged, what is the nature of the load, what may be the frequency of the load, or what may be the shape of that particular item which has hit it. I think these are various things in detail when such recent advances in computational and experimental mechanics. I think such techniques when my faculty colleagues will utilize, I am sure they will be able to get the answers, and our students who will learn these techniques. I see that our Professor Kong, who is from South Korea and who is also our our faculty. In fact, here we welcome Professor Kong. I can see that Professor Tarun Kant, who is now at Hyderabad, but I know that he is from IIT Bombay and he is one of the stalwarts in this area of civil engineering. Sir, I welcome you also. Then I can welcome various other people from Technical University of Denmark, Professor D.R. Farham, then Anup Mehta from ANSYS, and then we have our chief guest, who is the main speaker, and Professor Griffith. Real Professor Griffith, I welcome you on behalf of the whole institute and my own personal behalf. All of us are very much eager to listen to your thoughts and share your views. We would have loved to see you on the campus here. My friends have said that this is a beautiful campus. We will definitely like to have you here in the most immediate opportunity that we get to see and get to have a non-pandemic situation. We would like to hear you. I know that this is a wrong time at your place, but you have been so nice to us that you woke up at this late hour and agreed to the request of our faculty colleagues and from IIT Kharagpur to be the chief guest. I welcome you once again and say that the participants all over the world who have joined and from various parts, I welcome them, and the students, if they have joined on this live streaming of the conference which is going on, first of its kind after the pandemic, one can say in this institute. So I welcome all of you and say that you will have a nice future. With this, I inaugurate this particular conference and wish you best of luck. Thank you very much. Jai Hind.
Thank you, sir, for sharing your valuable thoughts. Now we'll have our speech from our chief guest, Professor D.V. Griffiths. And to formally introduce the speaker to our audience, I invite Professor Damodar Maiti to the dais to introduce the speaker.
Good morning, everybody. Before I introduce Professor Griffiths, let me announce one thing, that our Honorable Deputy Director and Director Sir has told about our institute, and we are happy to show you the 8 minutes video about our campus. A virtual video will be shown tomorrow at 6 o'clock during the cultural evening. So I would request all participants, those who are missing our campus and would like to know the details of our campus, that will be visible from tomorrow from 6 o'clock. So generally we those who we are attending conference, apart from the technical session, we look forward to see the institute and the cultural program. We are very much interested on that, of course, and dinner. Dinner in any way we will not be able to provide, but we will be able to show you the virtual campus and also the cultural program performed by our institute residents. So that will be shown tomorrow. Now it is my honor to introduce Professor Griffiths, such a big stalwart. I am really honored to introduce him. Professor Griffiths is a professor of civil engineering at the Colorado School of Mines and was previously at the University of Manchester, UK. His interests lie in application of finite element and risk assessment methodologies in civil engineering. His papers on slope stability are among the most highly cited in the geotechnical engineering research literature. He is the co-author of 3 textbooks that have gone into multiple editions, including the Chinese language on programming the finite linear method by Smith and Griffiths. In fact, during my PhD, I used to follow this book, Smith and Griffiths book. Thank you, Professor Griffiths, that I could see you virtually at least. And also he has edited 2 another books, Risk Assessment in Geotechnical Engineering by Patron and Griffiths, and Numerical Methods for Engineers by Griffiths and Smith. He gives regular short courses on risk assessment in geotechnical engineering for practitioners, with recent offerings in China, New Zealand, Australia, Colombia, Norway, Canada, Taiwan, and USA. Professor Griffiths is an editor of Computer and Geomechanics and was on the advisory panel of Geotechnics. In 2017, he was named the Cross Canada Lecturer by the Canadian Geotechnical Society and received H. Bolton Seed Medal from the ASCE Geo Institute. He is a distinguished member of the ASCE and served as an ASCE director from 2010 to 2013. With this, I welcome Professor Griffiths to hear his address. Kindly start your address, Professor Griffiths.
Thank you. Can you hear me? Fine. Great. Conference organizers. Hear me? No. Sound is good.
We can't hear you properly. Can you check
dear.
your microphone a little bit?
I'm using my I'm using my computer.
Okay. Can you come closer to the microphone?
Okay. Is that a little better?
Yeah, please go ahead. Professor Griffith, please go ahead.
All right, thank you. Dear conference organizers, senior administrators, heads of department, keynote lecturers, and delegates. Thank you for your invitations to me to give a keynote lecture and to say a few words as chief guest at the inaugural session of this first international conference on recent advances in computational and experimental mechanics. I'm bound to say my keynote lecture tomorrow is more within my comfort zone as someone fairly accustomed to giving technical presentations. More general comments as chief guest for an audience with such broad interests presents greater challenges in some way. It is humbling, though, to be asked to be the chief guest at this historic University of IIT Kharagpur, especially in view of the other very eminent international speakers who are also participating at this conference. The chief conference organizers, the 2 mateys, are to be congratulated on their excellent idea to hold an online conference during these difficult times. It's remarkable how this online conference can have such similarities to a face-to-face meeting in terms of keynote lectures, parallel sessions, published proceedings, without anyone actually meeting each other. The sharing of information and recent advances in the many fields covered by this conference will be similar to the experience at a conventional conference. Delegates will meet virtually with old friends and make new contacts that will endure beyond the current pandemic. I was reflecting a little on the enormous breadth of mechanics as a research area. What other conference could combine the interests of departments as disparate as civil engineering, aerospace engineering, and Ocean and Naval Architecture. I identify primarily with civil engineering, and within that discipline, I work in computational geomechanics, applying finite elements and risk assessment methodologies to the mechanics of soil and rock. I usually attend much more focused discipline-specific meetings, but a conference like this brings home the fact that there is so much to learn from other disciplines, with considerable overlap of methodologies in terms of experimental methods and computational tools. The only thing I'll really miss from a normal conference is the cocktail reception. But who is to say what normal conferences will look like in the future? Conferences will surely return to some sort of normality when things settle down, but there will be many positive things we can learn from on online conferences that may be here to stay. I'm thinking, for example, of greater participation for students and other researchers around the world without the time and expense, not to mention the carbon footprint of the air travel involved. I suspect the organisers of this conference are already contemplating a second and third ICRACEM. The opportunity to speak at this inaugural session also made me reflect on a little on how my career led to this place. When pondering my future as an 18-year-old back in London, my father came home one day after chatting with a parliamentary colleague to announce that civil engineering is a good bet, son. So I ended up studying at the Manchester University located in his constituency. A master's degree followed at UC Berkeley in geotechnical engineering under legendary professors Seed, Duncan and Mitchell, confirming my passion for what the structural engineers refer to as dirt or soil mechanics, and inspired me to pursue an academic path. I am very fortunate to have collaborated with brilliant engineers who so positively affected my career. Any success I have had would not have been possible without the influence of Ian Smith from the University of Manchester, finite element pioneer and of course co-author of the book that Dr. Matey mentioned just now, Gordon Fenton from Dalhousie University in Canada, who taught me so much about probability and risk, and Jin Song Huang from Newcastle University, Australia, who excelled in so many areas of engineering analysis, from submarines to soils. This story, and maybe my accent, has probably confirmed your suspicion that I'm not a real American. I have spent the last 25 years of my life at the Colorado School of Mines near Denver, Colorado, but I was born in London and spent much of my early career in Manchester. I'm very keen on cricket, actually, having played in Manchester and Cheshire leagues, and for many years, but for a couple of years in the 1980s, one of my teammates at Chorlton was Farouk Engineer. Some of you may remember him. Quite an appropriate name for this conference. He had retired from Test cricket some years before, but was still an outstanding player, and we were in awe at how early he saw the ball as a batsman. My only disappointment in attending this online conference is that I will not get the chance to visit India and Kharagpur in person. I have been to India just once, many years ago, flying back to London from Japan. My late wife and I got off in New Delhi and spent 3 days there. We enjoyed it very much, and I truly look forward to coming back one day. Finally, I should mention I have a strong family connection to India. My grandfather was born in Rawalpindi in 1901. Then, of course, that was in India, and he went to school in Shimla. His father, my great-grandfather, was based in India for over 30 years as an engineer working for the North Western Railway. let me close by wishing you once more a very successful and productive conference. Thank you once more for inviting me to participate.
Thank you, Professor Griffith, for sharing your views and spending time with us. Definitely, we'll get another opportunity to hear you in your keynote lecture. Yeah. So now we'll have the release of our e-proceedings of the conference. I would request Honorable Director, IIT Kharagpur, Professor V.K. Tewari, to do the honor, please.
PIP. PIP.
This arrow you just press. Yeah, this arrow. You press, but you didn't say the press.
Yeah. Just you can press it.
Synchronize press.
No program is complete without a proper vote of thanks. To give vote of thanks, I invite Professor Punit Kumar Patra to the desk.
Professor D.V. Griffiths. Professor D.V. Griffiths, our chief guest, Professor V.K. Tewari, Director of IIT Kharagpur, Professor S.K. Bhattacharyya, our Deputy Director, Professor B.N. Singh, our Registrar, Professor Swagata Dasgupta, our Dean CEP, Professor Nirjhar Dhang, our HOD, and Professor H.V. Warrior, HOD of our Ocean Engineering Department. My esteemed invited speakers, my fellow colleagues and participants, a very good morning to you. I am Dr. Punit Kumar Patra from the Civil Engineering Department, and it is my honor and privilege to give a vote of thanks to all those who helped make this conference a reality. We would not be here without the generosity of IIT Kharagpur and its administration. So, first and foremost, I'd like to thank the administration of IIT Kharagpur for giving us the necessary approvals for holding this conference. Next, I would like to thank the experts from across the world who have kindly agreed to give the lectures and chair the technical sessions in our conference. I thank you from the bottom of my heart for taking time out of your busy schedule and for agreeing to be a part of our conference. The next order of thanks goes to all the participants from across the world and their overwhelming response to our conference. Just to give you a brief idea, the basic idea of this conference began in the middle of May, with the health pandemic ongoing across the world and regular academic activities getting disrupted. Organizing a conference of this kind would not have been possible without the tireless efforts of the organizing committee, our student volunteers, and the support staff of IIT Kharagpur. In this regard, I'd like to thank Professor Damodar Maiti, who first initiated the idea of this conference, Professor Deepak Kumar Maiti, the technical chair of this conference, Professor Prosun Jana for looking after the website and its associated issues, Professor Ritvik Ghoshal for taking care of the online platform, Professor Chetan Mistry for looking after the financial matters, and Professor Saud Afzal for contacting and bringing the sponsors, ANSYS, Bentley, DHI India, Tescon, Ednex, and Electrono. Our sponsors deserve a big thanks for lending us the support during these uncertain times. We are also grateful to the Center of Educational Technology of IIT Kharagpur for the support they have provided throughout for holding this conference. With this, I conclude this vote of thanks and hope that you will enjoy the lectures and the technical sessions organized as a part of our conference. Thank you.
Now we bring forth to you the popular lecture by Professor C.D. Kong, and the session will be chaired by Professor Nijhar Dhang. Yeah, Professor N. Dhang is the present HOD of the Civil Engineering Department. Now I hand over to the session to Professor Dhang. Please, sir.
Good morning, Professor Kong. Can you is it possible to show both of them? Huh? Yes. First, let us make that one the connection.
Yeah. Professor Kong, can you hear us? Professor Kong?
You could please share that.
Just share let us share the presentation one second.
Can you share your presentation?
Well, I cannot click on that.
Yeah, okay, please wait, we'll make you presenter first.
Yeah. Can you make the sharing?
Hey, Kong, I'll do that.
Please make the sharing.
Yes.
Now it's okay. Yeah. Well, now. Yeah. Just a moment.
Yes, Professor Kong, we can see your slides.
Yeah, okay.
Yeah. Okay. Yeah, now go ahead.
Okay. Good morning, Professor Kong, and it is my pleasure to introduce Professor Chanduk Kong, and department also affiliated of the Department of Aerospace Engineering IIT Kharagpur also as an international visiting professor. The talk of presentation, structural optimization of an automobile hood using natural flex fiber reinforced plastic composites and rim manufacturing method. And also it is my pleasure to introduce with certain background highlights of Professor Kong. So please, so such a stature of Professor Kong, so please bear with me all the participants for a few minutes. And let me introduce Professor Kong. Professor Chanduk Kong graduated with a BSc in Aerospace Engineering from the Korea Aerospace University National Honors and a PhD in Aerospace Engineering from the Osaka Prefecture University, Japan. He worked as head of the Aero Propulsion Division of ADD, that is Agency for Defense Developments in 1978 to 1994. He served as professor at Department of Aerospace Engineering of Chosun University during 1994 to 2016 and was appointed as Dean of the School of Aerospace and Naval Architecture Engineering in 1999 and 2005 to 2006 and Dean of the Facility Management Office at Chosun University in 2011 to 2012. He has served as International Visiting Professor at Department of Aerospace Engineering of IIT and as an invited professor at School of Aerospace and Mechanical Engineering of Korea Aerospace University in 2016-2019, International Visiting Professor at Summer School of BUA, Beijing University of Aeronautics and Astronautics, China in 2017 to 2020, and Emeritus Professor at Department of Aerospace Engineering of Chosun University since 2016. He was invited as visiting professor at Department of Aeronautics of Imperial College, UK in 2001 to 2002. Professor Kong has contributed greatly to the development of aerospace engineering in Korea, primarily through his roles as a non-standing director of KIAST, Korea Institute of Aviation Safety Technology, in 2015 to 2018, and then President of KNST, Korea Society for Naval Science and Technology in 2017 to 2018, President of SASE, the Society for Aerospace System Engineering in 2013 to 2016, President of ICRC, International Collaboration Research Center in Natural Composites, Chosun University in 2012 to 2014, President of KESAS, the Korean Society of Aeronautical and Space Sciences in 2010, President of KSPE, the Korean Society of Propulsion Engineers in 2007 to 8, President of Korean Society of Naval Science and Technology in 2018, Chair of Cycle Innovation IGTI ASME in 2009 to 2011, President of RIME Research Institute of Mechanical Engineering, Chosun University 2006 to 2008, and the list is quite long, and because I don't want to give more time between you and Professor Kong, so Professor Kong has authored and co-authored more than 616 papers, including 67 SCI journal papers, and has received numerous lecture invitations from companies, research institutes and universities, and delivered 11 keynotes and invited lectures at international conferences. He has organized 28 national conferences, forums and workshops, and was co-organizer on 5 international conferences. Now I request Professor Kong to deliver your lecture. Professor Kong, please.
Thank you, Chairman, Professor Dhang, for your last introduction to me. Do you hear me?
Yes, we can hear you.
Well, you know, in the last semester that I stayed at the IIT Kharagpur as the international visiting professors. During that times, I enjoyed so much with the student and the department of the aerospace engineering academic staffs, especially with my two brothers, the Professor B.N. Singh and President D.K. Mighty. Sometime I met the conference chair of this conference, who is that Professor D. Mighty. That there are two the Mighties. So I enjoyed that tea with them so much. And when now is that I would start the my presentations. Very good morning, all of you, including the this conference VIPs, directors, the deputy directors, the registrar, the Professor B.N. Singh, and the conference chair, the Professor D. Mighty, and technical director, so that he chairs the D.K. Mighty. Well, now I would like to have the presentation with the title structural optimization of an automobile hood using natural flex fiber reinforced plastic composite, and RIM. RIM means resin infusion method, manufacturing method. Well, the contents of my presentation follow this sequence. Firstly, I will introduce what it is, what a natural composite, and I will introduce the target of this study. Then I will show you how to optimize the structural design for this target structure automobile hood. Then I will show you the resin flow the simulation to find the proper RIM manufacturing conditions. Then using this the simulation result, I like to show you how to manufacture the target structure hood. Then I'll talk about the structural test to verify that structural design result. Finally, that I'll make a conclusion. Well, this research was supported by Basic Science Research Program through the National Research Foundation of Korea, funded by Ministry of Education. Some part of this research works published in the essay journal Composite Part B. Somebody who interested in this study, that please refer to these published papers. Well, you know, for the last several years, many interest to use natural fiber have been increased due to the environmental program of the man-made fiber in the composite materials. Natural fibers have some the advantages such as the cost-effective recycling and low energy consumption due to the obtainable from the natures. Additionally, it has some more the advantage such as eco-friendly short storage biomass product, light products, good breaking, compression and torsional strength, non-abrasive, not lead to injury if broken, odorless, good vibration damping, and low cost. What is that? Well, there are various natural fiber composite applications, such as the automotive, aerospace, railway, sports and lasers. I'll show you several application example. For instance, the automotive interior parts using hemp flex mat and the press manufacturing method, cosmetic packaging. It was the interrupt to that something long. Well, what's that? Some problem. Oh, and the grinding disc using the hemp polypropylene and the injection molding method, deck and furnitures using the wood and polypropylene or the polyethylene and the extrusion method, bicycle frame using the flex carbon hybrid composite and the tape winding methods. You know that a natural fiber classified into the plant-based natural fibers and animal-based natural fibers. Plant-based based natural fibers from the can be obtained from the bast, leaf, seed, fruit, wood, the stalk, and grass. Following the table shows that the several kinds of the plant-based natural fibers, such as the flax, hemp, jute, canapa, evercork, bamboo, coir, lemmy, sisal, canacan, and so on. Among them, flax has the relatively high the mechanical properties compared to the other natural fibers. I heard that the India is the produce large amount of the jute, the hennacans and coils. Maybe that in the near futures that you can use these natural fibers for the structural designs. This slide shows that several kinds of plant-based natural fibers. Among them, the flax has relatively high the cellulose content. If the cellulose content is higher, the mechanical property is better. This slide shows the comparisons of the mechanical property between the glass epoxy composite and a flax vinyl ester composite. As you see that flax vinyl ester fabrics elastic modulus has the very similar to the glass epoxy fabric. However, that strength is the little bit lower than the glass epoxy fabric composite. However, density is very much lower than the glass. So that the specific stiffness and the specific bending stiffness is better than the glass, and also that specific strength almost the same as that the glass. So that's why we can use that flex vinyl ester fabric composite can be used for the structural design. Now I talk about how to select the natural fiber for these studies. Jute, flax, and hemp have the highest cellulose content. As I mentioned previously, if cellulose content of natural fiber is higher, mechanical property is better. However, it is necessary surface treatment because of difficulties of polymer infiltration in fibers. So that generally we use the sodium hydroxide for this purpose. So finally, the flax fiber is selected as a natural fiber to be applied to the eco-friendly target structured food. It has better vibration absorption behaviors, cheaper and easier procurement than other natural fibers. Recently, several applications of flax fiber increase for the aircraft door, automobiles, interior tennis racket, bicycle frame, table, building structure, and mobile phone case, and so on. Following there, two pictures show that selected flex biaxial woven fabric 600 grams per square meter and flex unidirectional fiber 275 grams per square meters. This slide shows that the flex fiber, the fiber surface morphology taken by SEM, scanned electronic microscope. Now, as I talk about how to select the legend for these studies. Legends for the plant-based natural fiber composite is mainly divided into thermoplastic legend, thermosetting legend, and biolegends. As you know well, in this thermoplastic legend, there are polyethylene, polypropylene, polyamide, and so on. In the thermosetting resin, there are epoxy, phenyl phenolic, and so on. In the bioresin, cashew nut shell oil resin, green box, and so on. In order to select a proper resin for this study, mechanical properties of the polyester, phenyl epoxy, and phenolic are investigated. Among them, phenolic resin has excellent flame resistance. However, it has the disadvantage of manufacturing process difficulty due to the high temperature high process temperatures. Epoxy resin is widely used for the carbon or the glass fiber composite as well as for the natural composite. However, it has this disadvantage, which is the relatively high price and brittles. So, firstly, we selected the vinyl esters because this is the cheap price as well as the low lead viscosities, even though somewhat low mechanical properties compared to the epoxies. Finally, we select the resin polyvinyl ester KRF 1031. However, we select alternative resin green epoxy for the near future studies. Now I would like to talk about resin infusion method RIM manufacturing process shortly. Recently, resin transfer molding RIM process method used for the manufacturing largely complicated shapes composite structures. RIM is method of injecting the resin into the preform enclosed by the mold. Preform is made of dry fibers, fabrics, or mat prior to injecting the resin. If the resin injection pressure is less than 0.7 megapascal, low viscosity and high molecule resin should be used. RTM is divided into several methods such as RTM, vacuum assist RTM, vacuum assist RTM light, and RIM, resin infusion method. As I mentioned previously, this study adapted the RIMs. The RIM manufacturing process, the resin infused only by vacuum pressures. This vacuum can help to remove the gas or air from the preforms. RIM method uses the solid stiff mold for one small surface with the resin flow outlet port on the vacuum, while the vacuum bag or soft mold with the resin flow inlet port on the other lap surface. Due to the resin infusion into preform by only vacuum, fiber volume fraction can be improved by reducing that void and void from the preforms. However, the disadvantage is longer gelling, longer the resin filling time. So RIM is limited use depending on the structural size and resin gelling times. Following that figure show that several resin infusion methods. Among them, resin has the one hard mold and the vacuum bag or the one soft mold, as I mentioned previously. And RIM method has low the initial capital investment, high manufacturing consumables, one side find the surface finishing, long resin filling time, and high volume fraction compared to the RIM methods. So this work is to carry out an optimal design of the small compact automobile food structure using the eco-friendly vinyl ester natural fiber composite to meet the automobile company's requirement, including strength, stiffness, and head injury criterion requirement, and manufactured properly the designed food using RIM, resin infusion molding method, through the resin flow simulations. To measure the mechanical properties, firstly we manufactured the like these the panels. So following the picture show that how to manufacture the panels. You see, firstly laying up flex fabric on the low mold, then enclosed by the upper the flex the mold, and mounting channels and input the port for resin, outlet port for vacuums. So then after that is vacuum bagging and installing and heat element, then resin infusing by vacuums. So finally we manufactured like this flex vinyl ester composite laminated panels. Well, with this, we manufactured the specimens to measure that mechanical properties such as tension, compression, flexure, in-plane shear, and interlaminar shears. We got the 5 specimens for type test to get the mean values. All these tests follow the ASTM standards. Following picture show the tested specimens for tension, the compressions, fractural and in-plane shear, and other the interlaminar shears. Well, this table shows the mechanical properties of the biaxial fabric flex vinyl ester specimen using the RIM methods. Measure the volume, fiber volume fraction was the 40%, and this is we measure this tension, compression, flexure, in-plane shear, and interlaminar shear strengths, and also the modulus 2 and Poisson ratios. Well, now I'd like to talk about the structural optimization. As you know well, there are mainly there are 3 types of structural the design optimization methods, such as the shape optimization, size optimization, and topology optimizations. For these studies, we used 2 the optimization methods, such as the topology optimization and size optimization. Actually, the target structure divided into 2 parts, including the inner panel and skins. Inner panel act as the stiffener. So in the topology optimization, the object function minimizes strain energy, or that maximizes stiffness to satisfy multi-load cases. And the convergence criterion is the 40% material mass from the original mass. And design parameter is density. But for the skin and inner panels, the size optimization, as I mentioned, we adopt the size optimization is object function, minimize the mass or the weight. Design parameter is skin and inner panel thickness. Well, as you see, topology optimization is carried out on the domain except for 15 millimeter offset area for ceiling consideration of car bodies. And also that we have several constraint load cases given by the Korean automakers Hyundai and Kia. And also we used the structural steel for analysis convenience at initial the topology optimizations. And also we use a commercial FE tools ANSYS shape optimization. And introduces the load cases. There are the 4 load cases. Load case 1 is bending stiffness, which means that after fixing A and B point, applying 100 the vertical load at C point, deflection at this C point, it should be less than 3 millimeters. And load case 2 is a torsional rigidity conditions. After fixing A, B, and D points, applying 100 the Newton vertical load at E point, torsional rigidity should be more than 150 Newton meter per degrees. Now that we have the 2 additional the load cases for skin rigidities. It's after fixing A, B, and C point, applying the vertical loads E, F, G, and H pointers on the 100 diameter area, the vertical deflections should be less than 1.5 millimeter at 50 Newton load, and the vertical deflection should be less than 15 millimeter at 200 newtons. So that for this the optimization, as I mentioned, we use the commercial code ANSYS shape optimization. This figure shows that mesh generation result for the topology optimization. So through the many iterations, finally we got like this the configuration of the inner panels. However, we could not manufacture like these structures, so we have to modify slightly this lecture. So the modified reverse modeling is carried out at a CAD tool by using the coordinate of the major load obtained from the first topology optimization result. Then move to the size optimization of the skin and inner panels. Here, as I mentioned, the object function was to minimize the weight, design parameter skin, and inner panel thickness. But in this case, we have to satisfy all load cases, such as the bending stiffness, torsional rigidity, low load stiffness, and high load stiffness conditions. And also for this size optimization, we use the biaxial fabric unilateral composite material properties. So finally, we got design result. Skin has 3 millimeters. Inner panel has 16 plies. Each ply thickness is 1 millimeter. Estimate weight was the 10 kilogram. So we could reduce that the weight by the 33% from the original steel the food 15 kilograms. Now that we carry out a structural analysis, the following the figure show that the structural analysis result at the load case 1. See, vertical deflection at the loading point was the 2.8 9 millimeter, which is less than the requirement 3 millimeters. So that our design satisfies design requirement. And also we checked the max stress, which is that 9.5 megapascal, which is less than biaxial flex pinilateral composite strength. And also that the following figure show that the structural analysis result at the load case 2. We calculated the torsional rigidity as the 898 Newton meter per degrees, which is greater than the design requirement of 150 Newton meter per degrees. So this case also satisfies the design requirement. And also, we checked we got the structural analysis result for the structure load cases 3 and 4. Here, see that max skin stress was the 40 megapascal at load case 4, which is less than the natural composite strength. So it also that confirmed the structural safety. And also we checked the deflection, which is the 1.2 millimeter. That is the less than the high load, the stiffness load case for the requirement 15 millimeter. So this case also satisfied design requirement too. And also we checked the natural frequencies. Here this figure show that, and table show that mode shape, natural frequency mode shapes, and natural frequency values. Here you can see the lowest frequency 162.5 hertz, which is then engine maximum the rotational speed of 3,500 RPM, means that 58 hertz. So the engine NPMs are the less than this the fundamental natural frequencies. So there is no resonance with the engine rotational speeds. Now I'm talking about the head injury criteria. We applied the EU pedestrian protection regulation criteria for adult. Here, the head impact model diameter is the 165 millimeter, weight is 4.9 kilogram. Impact on the food at speed the 40 kilometer per hours. With this direction, the angle is 50 degrees. So impact analysis was carried out using the commercial code ANSI Dynas. Head injury criteria, HIC, defined as these equations, where AT is acceleration of head impact model, T2 minus T1 is around 3 to 36 milliseconds, generally the 50 milliseconds. So after obtain the acceleration of the head impact model using Einstein, then finally we found the HICs. According to Euro NCAP's test conditions of the HIC, if food has less than HIC less than 1,000 is good design. Between the 1,000 and 1,350 is adequate. If the around the almost reach to the 1,350 is marginal. Over that, this value, that design is failed. So, according to analysis result, we found that HIC as 1,247. So we confirm the pedestrian safety, which is that adequate design. Our design is adequate design, and also we check the vertical deflection at impact point on food, which was the 109 millimeter. That is the vertical deformation is less than the 120 millimeter, which is the clearance between the engine and food. And also we checked the stress of food, which was 108 megapascal, which is less than flex composite strength 110. megapascals. So finally, we got this like this structural design result. With this 1,333 length is 310 millimeters. Ply thickness, no, it's a skin has the 3 plies, the 3 millimeters. Inner panel has the 16 plies and 16 millimeters. So now I'm talking about the resin flow simulations. For the infusion process, we have to consider the following the several considerations, such as resin viscosity, resin flow velocity, injection pressure, and resin gelling times. If resin infusion time is longer than gelling time, initial curing and void may occur. So we needed to find the proper the condition for the resin infusions. And also when you design the mold, you have to consider the following the several consideration factors, such as the location and number of resin infusion port and vent for the vacuum port, and provision of a channel or runners. In order to find the optimal manufacturing process conditions, resin flow analysis should be needed. For this purpose, we use commercial code Polyworks. The Polyworks program is the very expensive code. Polyworks is coded based on the Darcy equations like this. Here the T is a time, resin flow time, filling time. Nu is the dynamic viscosity, eta porosity, K permeability coefficient, delta P is a pressure gradient, and del is the structural length. So the following slide shows that procedure of the resin flow analysis. Firstly, we find that flow characteristics through the measurement of physical and mechanical properties of the fibers and resins. Then agree to modeling at meshing of the analysis and model configuration using preprocessor. Then finally, we got the visual simulation of the numerical solving result using the post-processing. But however, to the analyze that the resin flow using the Polyworks, we have to get that permeability coefficient. So to measure the permeability coefficient, when we use that like this permeability measuring device and HD chems. And also that we have to validate the analysis methods. So that we use the experimental operators. So following the figures and the pictures show that comparison between analysis result and test result. It showed that comparison the resin filling time reached to the radius of the 50 millimeters. So test result was that 480 second, analysis result was 445 seconds, and also we measured the permeability factor as like these values. So in the resin infusion, there is generally 3 strategies like this. Here that red line and arrows means that resin channels and resin input ports, and blue lines and the arrows means that vacuum channels and outlet port. Among them, the C strategies has the fast resin flow, However, it can generate easily the void and accumulate the surplus legend in that legend port. However, these strategies, even though that it takes the long infusion time, however, it can remove the void successfully. So these studies adapt these strategies. We call this channel, sometimes we call as the learners. Following the table shows the legend flow analysis, the input conditions. Here that RIM used only vacuum pressure, which was just one bar, and a channel diameter is a vacuum channel diameter is 15 millimeters, and also the measured value, the fiber permeability, viscosity, gelling time, and fraction, fiber volume fraction. The first analysis without the learner. So, this is so that the legend flow analysis result without learner, you can see legend infusion time was 17,200 seconds, which is over the legend gelling time 3,000 seconds, 50 minutes. We cannot use this strategies. So that we applied that, installed the learner with the diameter is 15 millimeters. So does not work the simulation. Anyway, so that through these simulations, we found that legend infusion time 2,406 seconds. So, which is less than the gelling time, the legend gelling time 3,000 seconds. It is successful. The cases. So we will use this simulation result for the manufacturing using the RIMs. So using this, the RIM, the simulation result, the insert biaxial flex fabric preform on the steep mold. This is steep mold. An outer surface on the mold, as you see. Then vacuum bagging. Looks at the vinyl sheet is vacuum bagging, and installing that legend input port with learners. This is learner, and this is a legend filling tubes. And this is the behind the point. This is the vacuum outlet point with the channels. So following that, pictures and figures show that the comparison between the experimental test and the simulation result. This result show that legend infiltration at 20% filling at 150 seconds after the starting the legend fillings. You can see the filling inflation pattern is very similar to the analysis. So that finally we could manufacture like this, that the panels. So we measured the filling time, which was that 2,700 seconds, which is very similar to the analysis result 2,460 seconds. So finally we got like the manufactured prototype food. This is the outer surface skin surface, and this is the inner skin surface. Measured the manufacturing food weight was the 10.24 kilogram. This is very much close to the designed design estimated weights. Then we carry out the structural tests to verify that structural design and analysis result. This picture shows that structural the setups. This structural setup, including the structural test, the hydraulic actuator, loading system, including hydraulic pump and controller, and also it has the strain, the acquisition system and cables and softwares. Structural test was performed based on the load case 1, which is the bending stiffness requirement. After fixing A and B point, two hinge point, you see, by clamp, then 100 Newton is applied to the C point by the hydraulic actuators. And the vertical deflection at the C point was measured by actuator strokes. And also we measure the strains by the strain gauge and upper and low surfaces. This is the strain measured result. And the following that table show the comparison between the analysis and test results. As you see, analysis result well agreed with the experimental result. So now I would like to make a conclusion. An optimal design of small compact automobile food structure using eco-friendly flex pin-elastomer natural fiber composite to meet automobile companies' design requirement, including strength, stiffness, and HIC requirement, has been carried out. RIM's manufacturing conditions were found through the resin flow simulation and properly manufactured using this simulation result. Structural test was carried out to confirm the design result. The measured strain and deflection are well agreed with the analysis results. This is the end of my talk. Well, before ending my talk, I will talk about one more. Well, based on this result, we developed the agricultural automobiles container already, and also now we are developing the horizontal axis wind turbine blade, which is a 30 kilowatt the class. If it will be successful, then we will move to the large scale. It's a 1 megawatt class, the wind turbine blade using this natural fiber composite. India has the so many opportunities. So because you produce, as I mentioned previously, you produce so many the jute, the coils and Hennekens. Now it's just why that natural fiber manufactured just sacks and loaves only. But however, you can use these ones for the structure. Then you can use that value, that increase the value so much. Thank you for your kind attention. Thank you.
Natural fiber with
Any comment and question or?
answer, just a little bit summary, and then I shall come back to the question answer. Okay. So, and then resin manufacturing process, then scanning with microscope with comparison with the following ASTM standards, and then inner parts, then scheme, topology optimization, and many more things actually for a lucid presentation. And now, thank you, Professor, once more for this excellent presentation. Now open for discussion. Yes.
I cannot hear your voice.
Can you hear now?
Now it's okay. Now it's okay.
Okay, fine. Actually, I have just simply just little bit summarize your presentation, starting from,
Yes.
says on the natural fiber, that in a chronological process up to the optimized shape of
Yeah.
example resin manufacturing process, that RIM, and following ASTM standards, then your inner part and skin topology optimization, shape optimization, and then showing the structural setup and coming to the final product. It is an excellent talk, Professor Kong. So now I request the participants who are actually attending this one online, if you have any question, please come one by one. So
Okay.
So I
Okay,
think,
that.
okay, so
At the moment is not enough time to discussion. So anyway, that the Professor Dhang is your summary is quite the correct, the well summarized my talks. Thank you for your introduction and summary again. And somebody who that is interested in this study, that that you can send me that email, or that you can use that like this Google link, or that Google this one is the Microsoft Teams, and so on. We could communicate more. Well, if the coronavirus will be stabilized in the near futures, I will attend the lecture in the coming spring semester in the next year. At the time, I can meet you closely. Then we discuss more about this. Thank you for your kind attention once again.
okay, thank you, Professor Kong. Thank you very much. So once more,
thank you.
Thank you, Professor Dhang, for chairing this session. Now, I request all the participants to attend other two keynote lectures going on. So the one lecture is by Professor Kant. The link is given. You have to click the link PK Patra. And another keynote lecture is going on, that is by Professor D.R. Furman. So that link is also given. You have to click MS Abjal, that link. Okay, so that lecture might have will be starting, I think, soon, or might have already started. So please, you can leave this meeting and join the other link quickly. Thank you very much. Please join the other lectures after leaving this meeting. Yeah. Okay. লগ আউট করে দিচ্ছি আপনার এটা কোশ্চেন আনসার নিলেন না এটা খুব পার্টিকুলার